gonna start recording this, and then what I'm going to do, I'm gonna make Italo a host, and if somebody joins, he just have to admit them. Where is it? Here you are. Make host. Okay. Change host. And I think we are ready to go. It's now, I'm gonna do a tweet on Twitter, and people can watch us from Twitter as well. Okay, yeah, we are ready to go. Just make some more introductions, and I think we are good to go.
Yeah. Would you like to start, Italo, or should I?
Yeah, just go ahead, start. Yep.
Oh, so yeah. First, thank you for everyone watching this workshop. The idea is to bring some information about how to connect hardware with other kind of interface. And for this one, I'll be using WhatsApp because like everyone's in Brazil loves WhatsApp, and since I'm a Brazilian, I had to do something with that. And first of all, I'd like to introduce myself. So my name is Luis Leão. I'm a developer evangelist at Twilio. Since it has been 1 year and a half. So in October, I'll be doing 2 years at the company. And here are my contacts. So if you're developing something using Twilio, you need to help, and you need help, or you need to discuss or share some thoughts, please feel free to reach me and contact me through email, through my social media, or if you'd like to see some samples. I'm sorry, because most of them are in Portuguese, but here is my GitHub page. So about our workshop today, I have 5 topics to cover. Is in Portuguese, so I translate. The first one is about working with IoT platforms and understand which or what kind of platforms we have to use right now. The second one is about how to build the hardware. Then the third part would be understanding the hardware connecting to the cloud and how the data works through this from one point to another. And then next we'll be talking about WhatsApp integrations and what you need to do or understand to make your hardware being controlled by WhatsApp. Of course, WhatsApp won't run on your hardware, so you need some backends or some connections between them. And at the end part, you'll be working on. We'll be working on. Sorry. So at the end part, we'll be working on the streaming data. When will be possible to, for example, grab data from the hardware, pass it through the cloud, and then connect with any other kind of systems you would like to use. So if you'd like to, for example, add machine learning to this, you could grab a stream of data from the cloud and then storage it in some place, for example, Google Cloud Storage or any data warehouse you would like to. So that's the main items to build that. So first, what was my intention about creating this project from and integrate with WhatsApp, right? So I live in Brazil in a condo that had some common, some public places for the people who live in the building that have some kind of like pools, saunas, jacuzzis, and all sorts of leisure you can find on a building. So every time I try to use some of them, they look like this. And if you see this blinking that way, that means isn't working anymore. So by the way, if you have any questions, please feel free to ask it on the chat. So I'm seeing the chat screen too. And if the first thing you think about seeing that kind of image when you are inside the jacuzzi is like, okay, can I be electrocuted about that? And I don't know how to answer that. Probably not, but that's not the the good behavior of some hardware working like that. And what happens is the manager of the building have to each month buy one of these again and again and again, because this one, specifically the two of those bathtubs, is on the top of the building receiving sun the entire day. So in a month, this cover, the protection cover, just peel off from the console, and the water gets in, and then that happens. So that's was the main reason I would like to build this kind of hardware. And also because if I create some kind of interface that I can tell which people could have access to it, and also how the manager could understand the behavior of the people using the common areas, that's something that interested me. And I would like to try a new interface instead of have a physical interface there. So I can just take that off from the bathtub and then connect through any different kind of interface, and also add more intelligence into the process of using those areas. So to begin that and thinking about our plan today, first part we have to talk about is the platforms, right? So before telling about the platforms, we need to understand that we will be connecting to some hardware. And when I'm talking about hardware, it's like we have some, since we are planning to automate a bathtub, a jacuzzi, that means they have the water bomb, and also the heater, and also some sensors to understand if that could be turned on, if there is water inside, or if the temperature is the temperature you like it. So we need a hardware that also can receive sensors and also connect to actuators. But this hardware also needs to connect to the internet some way. So there's some specific hardwares we can use, and that's what I'll be talking about now. And also, when you are developing hardware, right now it's much easier to develop if, for example, you use Arduino or any other open source platform. So right now, Arduino is a pretty good start, because we have a strong community building libraries. You have too many examples about how to connect a specific kind of sensors, displays, actuators, and anything you can imagine. So you don't need to start from scratch, and that's the beginning of that. But, and there's a but here, we are developers, and usually I open the Arduino interface, and you could see it's not friendly. It just looks like more the notepad than anything else. I just have some multiple projects open here. Let me add a new screen here so I can just show you the interface. And the interface is like that. You just have the text area. You have to put your code all here, and then you have just 5 buttons on the screen: one to build your code, another one to upload into your device, your hardware. So when you are building code for hardware, we call it firmware. And we have also buttons to create a new file, open an existing file, or saving this one. And beyond that, we have also some kind of serial monitor, so we can debug what's happening on the hardware. And the only way you can debug things on hardware is like, or you build an interface using lights, displays, actuators, or any kind of controllers like that, or debug through the serial port. And that's the only way we can do that. So it's not friendly for developers. And I prefer to use something like Visual Studio, so we can build our code here and then deploy. And also there's a friendly interface that also could brings things like autocomplete and stuff that make our life easier. So I will close the Arduino here because we are not using that today. We'll be using Visual Studio. But to start using Visual Studio, there's a platform called Platform.io. So the website is platformio.org. And is a way to connect multiple platforms and boards and have also a strong community, create code and code samples and libraries to work with. So the first part you have to do, you need to install the Get Platform.io on your Visual Studio and run this little tutorial about adding the plugin into your developing environment. So you'll be working in multi-platform. You just need your Visual Studio Code and add the plugin. Also, the other part is like, let's talk a little about the hardware, because what platforms I will be doing for us is like, they will make the environment, the developing environment in a better way we can develop it. So after we have that, we need to add some libraries to make your hardware connect to the cloud, right? So the next part I would like to talk about is more about the hardware itself and how you connect this hardware and use Platform.io, right? So I will need some time so you can download the plugin and follow this little tutorial here to get the Platform.io ready on your device, right? So we have to install the VS Code. Just a second. If you install the Visual Studio Code, you just search for the Platform.io ID extension. So I did already this on myself, on my ID. So I just had to type Platform.io, and it's here. You have to install, right? So that's the first step to make your Platform.io working in your environment. Once you have done that, on the bottom, you see this home button, and also other buttons here that are related to the hardware and the connections. Okay, so the home, when you click on the home button, we will open the home for the Platform.io, which is this interface. And you can see if you have built a project, your project will be there. You'll be here. You can open your project, right? So you can create a new project here. Choose the board you're using with. So I can create a test project. I need to select a board. For this one, I'm using ESP32. Let's see. Which one do we have here? So we have the DoIT ESP32 DevKit V1. It will depends on which ESP you are using with. So that's why there's a lot of options here. So the most common is the DoIT ESP32 DevKit. Okay, so I can select here. And also you can choose the framework. So you can still develop using the Arduino option, or if you would like to use the Expressive, which is the maker of the ESP, you can use their own framework. Okay, so I won't create that because I already have one project here. So I will be opening my my current project that has some code. Thinking about the hardware itself, so I talked with you a little about the ESP. So let me open my other camera here. So so you can see my camera, and that's some hardware. That's the kit, the working project, right? So I have a prototype board and also a resistor, the two sensors, and also one actuator with two relays. But I would like to show you first some of the hardwares we can use for this project. So when I'm talking about the ESP32, is this one. And what happens, let me see if I can zoom a little. So what happens here is that this version of the ESP have also Wi-Fi and Bluetooth. So if your project needs to use both of the technologies, you can use that. But there is a smaller version that is cheaper. It's called ESP 8228. Let me check. 8266. And that's the version that only has Wi-Fi. So first thing you need to have in mind is that use a hardware that considering how much would you like to spend with it, and also which features you like to use. And also ESP32 have more memory, and so I try, since I have a lot of this in my house, I chose to use the ESP32. About the SP8226, there's some form factors. This one is called Wheel. It's from Seed Studio. And they have those kind of connections here. So it's easier to plug some prototype sensors that use this form factor. This form factor is called Groove. So you can, for example, buy a Groove kit that has the temperature sensor, the relays, and everything else, and connect through this port. The bad part is this one, the wheel option, have less inputs and outputs if you compare to the ESP. So the ESP, here you see all the, each pin here, it's some kind of port. Some of them, so if I point here for you, something starting with D is digital ports, then there's 3 volts, ground, more digital ports, RX and TX are the communication ports, also another ground, another 3 volts. Here we have an analog input, ground, voltage, those S, I forgot what is, I need to check on the documentation. Also, some communications ports used, for example, network here, 3 volts, the reset button, ground, and the VIM. There's a little difference because between VIM and 3 volts, because VIM usually is the voltage before passing through the voltage regulator, because DSP use 3.3 volts instead of the regular 5 volts. And that's something you need to be careful, because sometimes if you try to send 5 volts on the ports or more than 5 volts, the Arduino hardware usually is a little more, how do I say that in English? It's a little, they can hold the voltage for a while, but it's still, for this one, it is more susceptible to be burned. So that's the only thing you need to take care. Oh, go ahead.
Tudo que eles estão streamando ali. Os caras estão mexendo nos circuitos ali.
Eu não entendi, desculpa.
É sobre o que mesmo, coisa?
O workshop, a gente está falando sobre a integração de Arduino, de hardwares, né, sendo controlados por uma interface no WhatsApp. Neste momento, eu estou apresentando a parte relacionada a quais são as portas digitais, né, o fato de a gente estar usando um hardware usando o SP32, porque tem Wi-Fi, e na sequência eu vou falar sobre alguns outros tópicos. Tudo bem, a gente está falando em inglês porque tem algumas pessoas que também são de fora. Tudo bem a gente manter em inglês aqui para você?
What we can do, if you want, maybe we can do a bit of the part in English, and then maybe we can explain some things in Portuguese if you want.
Okay.
And
so
depending how many people we have in that they are not from Brazil, so we might need to explain some things in English. But maybe the guy that he's from Spain, he might be able to
English is
understand
fine for him. Yeah,
yeah.
Okay. So let's continue. Thank you. So we have this form factor. Of course, the ESP in this form factor have more digital parts, so it's better if you, for example, in my case, I have some specific sensors that use communications protocols that I need specific digital parts that are not available on this form factor. So that's my main decision I need to do here. I don't have an Arduino board right now here with me, but kind of they look like the same. I mean, if you're using the digital part, doesn't matter if it's an ESP32 or if it's on an Arduino board. But for my case, I tend to use the ESP because they have the Wi-Fi built in, and I don't need to use a Wi-Fi shield or an Ethernet shield on top of the Arduino board to make the communication process, right? So thinking about the Jacuzzi, what I need to understand now is like how many components I will be using there. And like I said before, for the Jacuzzi itself, it's basically a heater and a water pump that make the water pass through this heater, and they have to turn it off if there's no water or there's a minimum level of water. And also if the temperature reaches the desired temperature or the maximum of 40 degrees, right? And so I believe no one would like to take a shower with more than 40 degrees Celsius, which in Fahrenheit, I don't know how much in Fahrenheit it is. Let's ask Google. Celsius to Fahrenheit. So it is 104 Fahrenheit. So when I went into the manager of the building, they opened the Jacuzzi for me, and I saw all the components. And it is like, it's pretty simple because I tried to do a reverse engineering of everything and took the manual and understand all the protections the bathtub have. And I just built this using the microcontroller, right? So I have here with me, right, just moving some hardware from that, the ESP32. So it's all tied here because, of course, I have to connect all the components. So here is the ESP. And then I have a relay, a board with two relays. So one will be controlling the water pump, and the other one will be controlling the heater. And also I have this probe that is a temperature sensor. I can show you the links where you can find it. And also I am using this little components that it should be installed on the part when the water is, and then if the water reaches this level, they will go into here. So this will float because of the water. And then if it's down, that means there's enough water into the tank. So you can see when I just make it up, the relays turn it on. So that means the hardware is already working with the cloud. So they're sending the signal to the cloud and getting back that it could be turned on, right? So that's my part. Every time this changes, they will trigger an update on the cloud and vice versa. Okay, so now I have this hardware here. Let's talk about how to connect them, because that's the main thing to make it work. So for the temperature sensor, I'm using this guy. I will put that on the chat so we can also find it. But the important part here, if you're not in Brazil, is to find these codes, because this is the code of the sensor, and you'll be the same wherever you are in the world, right? So that's the temperature sensor DS18B20. this site that sells this in Brazil also gives some information about, for example, which chip it's using. So it's the DS18B20, how much tension they need to operate. So this is using from 3 to until 5.5 volts. Also, how is the measuring for the temperature? So it's -55 Celsius. So -67 degrees Fahrenheit until 125 degrees Celsius. And for us, we'll be working only with like the ambient temperature, and also the maximum temperature will be 40. So I don't expect go beyond those thresholds. And also there's some kind of the information about precision, and it's half degree. Also the dimension of the cable and everything else, and also this important information that is a one-wire interface, right? So they also give me about the pinouts. So what is each function of each part of each cable on the sensor. And the important part here is brown is the voltage, red is the ground, orange is the signal. And I think the colors, yeah, mine is black, reds, and yellow. So I know the signal is yellow here. And also the sensor is waterproof, so we can use that in a wet environment. So in this page, we also have some examples. So if you are buying hardware outside, most of the suppliers also offers tutorials about how to connect them. And this one, they just bring me these schematics here. It's using an Arduino here, but the important part actually is this one, how the sensors connects the red into the voltage, the black into ground, and what is the connection through the sensor into the digital port, and also with this resistor. So the information from the technical specifications requires you to use a resistor here, and it's a 4.7 kilo ohms. Okay, so that's the Arduino part. Let's think about the ESP. And on my presentation, I have one here. So that's how I connect mine. And I'm getting on the voltage parts. I'm using the VIM because I'm be working on 5 volts here. And then this red is connected through this place. When you see these green points here, that means that cable here is connecting parallel with those here, with the yellow one. So this entire column is connected with each other. So I'm just connecting the red parts until here, and then here is connected to the voltage. And also the voltage connects through this one that is connected to the yellow part, which is the signal, and then connects to the digital pin here, right? So if I get information here, it's like the 32, 32, 33, 32. Let me see how many items. 1, 2, 3, 4, 5, 6. So we have like 6 pins below, and you can use that. Also, we have the ground here, and then the ground is just connected to the black wire. So that's the main part of the connections here. And about the relay, I didn't put the schematics here, but it's the same. I just grabbed 2 digital ports there, and then it's done, right? So let's go back into the Arduino part, the code part of the hardware, and then we start to tell a little about how you can use the cloud connection, right? So that's something that you have to use here. I'm adding the Arduino library here because my base interface will be Arduino, but also I'm using other libraries. So I just divide which is for what. So this first part is about, oh, sorry, JSON is required for this one. So the first part is about using the Arduino Arduino platform, and also OnWire and Dallas Temperature are two kind of libraries. I can open them, and they work about connect with some kind of sensors that uses just one wire to pass data through something. And that's why I had to add them, because one wire just makes the temperature sensor being readable, and you can send and receive comments from them. But Dallas Temperature is the library that have the protocol to ask specifically for temperature information, right? So I need to add them here. And then this second part is about the cloud connection. So I won't be telling, I will give details later. And what now I have right now here is like the digital ports I'll be using for each element. So I have those two for the water pump and also the heater. So those are relays. And the next one are about the sensors. So I have the sensor level that I showed you before, which is some kind of border that will float if there's water, and also the temperature sensor that is tied to the Dallas Temperature library, right? So, and also I just defined two other constants here. That is the minimum temperature and the maximum temperature that I'll be using as a fail-safe to understand and to take some actions. For example, if the temperature reaches more than 40 degrees Celsius, I need to cut off the heater immediately. So that's how I'll be creating my my kind of fail-safes on the project. Then I'm using OnWire to connect the temperature sensor. So one wire you'll be interfacing the communication part, and then Dallas Temperature is the library that connects the sensors to one wire, and then that you'll be used to receive the data, and specifically like the temperature data. I have other things about that is from the Wi-Fi part. So I just tell about a little later. And then I have some variables here that those variables and what I'm doing with the communication part is like I'm replicating all those variables into the cloud. So that's how I'll be understanding from the cloud part what's happening on the device. And then I could take some actions and also create some kind of log if I want to. So basically, the idea here is to all the variables on the device are duplicated into the cloud. In IoT, we call this a digital twin approach. So we have this kind of digital twin on the cloud that represents the same behavior and the same information from the physical device. And if you change the information from one side or from another, they sync with each other. And if you change from the cloud, the device changes itself, replicating this information. If something changes on the device, the clouds also change and make that communication the same information on both sides. I will just hide this for a while. And since you're talking with hardware, basically hardware have two main states. So the first state is about when the hardware is turned on. and they run a code once. And after that, we literally have a while true loop. So it's when if you're a developer, you are asking a little about like why. So is that okay with having a while true on your firmware? Actually, it is. But the point is here, we have this setup function that runs once, and we have this loop one that is just a while true. That's it. So the point is, if you code is just freeze, or if it breaks in one line here, that means it is like your hardware froze. So you need to make sure that all the information or all the actions you are doing on your hardware does not block this loop. For example, I can give you an example. If you are waiting to receive some communications from a serial port, you could ask them here, but you can just create a kind of loop that you'll be looping until you receive that information. Because if you're inside here and there's something looping here, that means they can go forward with the code, or they can, for example, check if you receive something from the serial port, etc. And since I'm using a client that is connected into the cloud, every time the loops runs here, I have this pull command that checks if there's something from the cloud that I should receive. And that's the reason it's on the beginning of the pull of the loop. And also, for example, if you create a function, a method here that didn't end, that blocks something, that means they won't go forward with your code. So, for example, I have this connection part, and let me just create some messages here because it was supposed to not appear. Okay, so if I, for example, I can, let me see if I put a block here. In this case, I didn't put, but here on this while, for example, if I don't have this return, I will just repeating this forever until my client is connected to the cloud. So that's why you need to be careful about those whiles, and especially creating some code here that could block your hardware. And once you block your hardware, there is nothing you can do until turn it off and turn it on again, right? So that's the main reason I'm using this poll here. And also on the loop is the place I need to check all the sensors. So for example, since I'm using digital ports when you're working with hardware, you have input and output ports. So on the setup, I have to define what's the behavior for those ports. So for example, the ESP32 have a built-in LED, so you can like blinks every time you connect with the cloud or you are transferring some data or anything else. But also I have the relays of the water pump and also the heater, and also the sensor, the water level sensor here. And that one, I use the information input pull-up, because if you are creating any kind of button on input that is changing signal from, for example, ground to 3 volts or 5 volts, that means you need to create a circuit. And the circuit is like this. Let me show you. You can find pull-up circuit. Let me grab some examples here. Okay, I think that could work. Check here. So you need to connect the ground into a resistor, into the signal port, and then connect into your button or sensor, and then connect to 5 volts or 3.3 volts, depending on the platform you're using. So you don't need to do that, and you can connect directly into ground and the sensor. Instead of doing this, you just connect the ground, the button, and then the input pin. But you have to create a flag into your code. So what I did here, I'm using this constant input pull-up. That means the hardware use its own pull-up circuit to connect that. The only difference is that when I read the information from the hardware, usually you read 2 values if it's digital, right? So one is high and another is low. So if you use this version here, input pull-up, highs means is off, and low means is on. So the button is pressed or is activated or something that means that that slide or that button is on. So you need to invert the logic here, right? So that's the only thing you need to concern about. And I use the pin mode methods to define the behavior of each pin on my hardware. But on the loop here, I can use the method called digital read, the function actually, digital read. And digital read, I add the pin I'd like to read, and then I'm just storing this on a variable. So if I'm checking if this is low, because lows means on, and if this pin is on, and the less information I have from this pin is different from the reading I'm having right now, I need to do something because the state changed. So every time the state of a pin changed, a sensor changed on my hardware, I need to do something. If I read the same value, usually you don't need to take any kind of action because it's like they didn't change what you expected. So is a smarter way to compare the level, the current, for this case, the level sensor, if the state changed from my latest digital read method. Okay, so once I check that change of values, I can take some action. So the first one, I'm just debugging on my serial part here, so I can like see and understand what's happening. But also, I can, if my level sensor is off, that means I don't have enough water on the tank. And if I try to turn on the pump without the water, it will be burned. So I shut it down. I create a function that just shut down all the relays, including the heater and the pump. And also the heater can be turned on if the pump is not turned on, right? And then I stored the information, the latest information from the latest state from the sensor into my main variable. And next, I just sending those informations to the cloud. So I'll be talking this a little later. I'm also, this is the first part about the level sensor, but the second one is about the temperature. So if I remind you, sensor is, I initialize on the top of the code, and then on the loop, I just on the setup function, I initialize the begin code, and on the loop part, I need to get the temperatures. So every time the loops runs, I'm asking for the sensor what's the current temperature. And what happens here is like I send the command begin again, then request temperatures. So the one wire send the command to get these informations. And then I can store the temperature using the function get temperature C by index, which means I'm getting the temperature in Celsius. If I would like to use Fahrenheit, I just change from C to F. And this index zeros means specifically for this library, and because of one wire, you could use multiple temperature sensors. So what's happened here is like, if you have 3 or 4 sensors, you can use index 0 until 3, right? And Lucas asked about what means the E. I don't know. I don't know how to say this E into English. I don't remember, but I can get here. And I think you are talking about this one, right? And just remind you guys, this is not JavaScript, looks like, but actually it's C, it's C++. So here, instead of passing the object, I'm passing the memory position of the object. It's really, that's some kind of thing you have to do in C. Oh, go ahead.
Is this a pointer?
Yeah, exactly. It's a pointer. So we are pointing to this object, but not the variable itself, right? So let's go back again. Where you are. There's some, I can remove these to-dos because I already done this on my code. So if your temperature sensor is not connected, what the one wire in the Dallas library does is they return a temperature below 136. Actually is, let me think, I can test that with you, but it's like the temperature came 137. So if the temperature came this value, that means the sensor is disconnected. And what I do is right now I'm just sending messaging error to the cloud to make sure that is that my backend knows that there's something wrong with the hardware. And also I did some security check-ins here. So first one, I just could activate the pump if the level sensor is on. So I could never activate that. And I started to do some kind of security checks here. So first, I'm using the method digital write. So I'm writing on the pin. And the digital write is just like, you can write high or low into this pin, right? So I'm using the port, which is 5 here, and the port for the pump. And this security verifications here is like, let me put some entries here so we can discuss about some info here. So first one, I'm checking if the pump is active or I'm in the cleaning state. What is this? The cleaning state is like the manager could turn it on just the pump for half an hour to pass their water to the filter. And then after that, I could turn on, okay, see you soon, Pedro. I can turn it on the heater just after the cleaning part is done, right? So if the bathtub is active, that means anyone that lives in the building could activate it, or if it's cleaning. And also I'm checking this bubble information came from the cloud. So it means if that is true, the cloud have the same information there. And this can activate bubbles. It's like, is my security part. So if the level sensor is on, and also on the cloud, the bubbles is active, and also the jacuzzi is active or is cleaning, I can turn it on the pump, right? So I just undo this. And I did the same thing for the heater. So first one is the pump active? And I can activate the pump. So I double check this info. And also the temperature, the current temperature is less than the target temperature I would like to program. So usually here we use 38 degrees Celsius. And also if the temperature is higher than the minimum temperature, which is 5 degrees. And also if the temperature is less than or equal the maximum temperature, which is 40 degrees Celsius, right? So I do those check-ins, and if everything comes through, I can turn it on the heater. So this can activate the heater is the security part, and I'm just in checking again here is like if the jacuzzi is active, and also I'm not in cleaning mode, so the heater can be turned on cleaning mode. And also the cloud tells me the heater should be on, and if I can activate the heater, I can turn it on the heater. Other thing that is important here, I'm using low and high in a position that looks weird, but that's because this hardware I'm using, I'll just get the camera here, just a second. This relay board I'm using here, they use the inversion control. So if I use low, that means it's on. If I use high, that means it's off, right? So that's why it's inverted here too. Okay, and also there's other things I do here. So that's the part of I just can turn it on and turn it off the actuators, the heater and the pump. And after that, I have this verification here. That is the last part of the code. That is mostly of the making sure that all the information is replicated onto the cloud. And I can start to talk about the cloud right now. So that's the last part. I put some debugging here so I can see the information running through. And also I'm sending some information to the cloud. And that's why I'm moving to the cloud part right now. So if you would like to create the hardware without the connection, the only part you need is having those actuators connect to the setting the pin mode for the actuators and for the sensors, depending if they are output pins or input pins, and also use all the libraries you need to connect with the temperature sensors, get the state of the level sensor, or any other kind of sensor you would like to use, right? Other thing, since now we talk about using platform IO and connect platform IO into the hardware, the next part is about talk about how to make that available through the internet. And usually, if you are working with IoT, there's a protocol called MQTT, right? So MQTT is a very old protocol that now is the mostly common protocol used for IoT, right? And that's because they are reliable, and also they try to shrink all the data so we can send more data even on bad connections or in places that the connections have some kind of limits, right? I just let me put this link on the chat too. So if you'd like to use MQTT, the first thing you have to do, you need to create an MQTT broker. That means you need to create a server, and that server will answer for the requests from the device. And okay, I'm a developer, I'm a little lazy, so I tend to use platforms that give me that as granted. Looks like, oh, thank you. So what happens right now is like I discovered a platform called Goliath, and this platform kind of no worries, Kaique. This platform kind of provides you an MQTT broker and also other steps to manage IoT devices. So I saw a friend started to work on this company. His name is Álvaro. And I saw a demo he did building something using Platform.io and connecting from the device into the clouds and replicating this on anything he would like. So I started to dig about a little more about it, and it's actually pretty easy to implement instead of like managing his own MQTT server, managing certificates and everything else to make sure your device is secure. So this platform is pretty good to work with. And they also have a GitHub page with some samples here. And the samples connects with multiple platforms. And this one here is the one I use it to as a base to develop my part, right? So I also add the GitHub link here. And for example, I have this weather sensor that have some kind of temperature sensor here. So that's my base code. And they giving details about everything you need to use to connect into the device, right? So there's, for example, how to use DSP, settings for the Wi-Fi, what more? They are using the Feather ESP to connect, how to management and do some uploads into the firmware, etc. So I have an account here, and let's see where I put my, yeah, that's it. So first thing you need to do is create a project. So I have a project already here. Cosmopolitan is the name of the building on where I live. And when I create the project, this project could handle multiple devices, right? So when I tried to build this, I was trying to not use some kind of database or anything that I would need to build a backend to check things and save it to the database. Of course, if I, for example, make that a product, I probably should use a database that, for example, could manage all the people living on the building that could have access to it, and etc. But since I'm not doing that, I did some kind of workarounds, which is some of them is like, this is the device, and the beginning of device, I put a code here, pipe, and the name. And this is here for a reason, because this code is the code I'll be using to identify or to activate the device. And when I have this device here, there is something that I could do. For example, Goliath, they have the option to make over there updates about the firmware. I'm not using this right now because I use in Platform.io, but that's also an option if you'd like to use. But they also brings me some information about if the device is online, when the device is created, let's report, and also information about the database state and some data streaming here. And also I have a credential for the device. So that's super important because if you're building hardware, the first thing you need to do is manage the keys from each device. And that's something that this information, this key is needed to connect your hardware with Goliath Cloud, right? And with that key, you don't need, for example, to manage the MQTT, manage the device state about the Wi-Fi and anything else. You just set the key there, use the command pull and use the command connect, and that's it. And then you send and receive data from here, right? So I have some information about logs here. So this temperature sensor disconnected is that command. I use it into my, let's move my camera from other place here. This client log error just put the record here, right? So I can see the last time that happens. What else? Also, the main thing I'll be using here is this LightDB state, which is all the variables I'm using on the device, and they change if I change something here, or they replicate each other, right? So I will be setting the auto refresh to 1 second. And for example, let's see if it's, there is here too, level sensor. Level sensor is 1. I move it into 0, 0. So every time I'm moving the sensor here on my hands, they will replicate. I also put this millis information, which is how many milliseconds passed after the device is on. So if you see this updating, that means the device is sending data to me, right? And if, for example, I would like to use the clean mode, I can just set true here. And then submit the data. And if I see the camera, only the pump is on. Okay, if I turn it off, if I lower down the sensor, everything turn it off because the fail safe. If it's up, the sensor is on, right? So that's the main thing you need about this using the platform. If you are just connecting the hardware to the cloud and getting some information, but if you're working in thinking about IoT, IoT is just not about turn it on and turn it off relays on the internet. It's something more complex, right? So I didn't create until now any kind of backend because just the hardware sending the data here. But you could also build something that, for example, every time something changes on the hardware, I could activate something from one backend, or depending, get all this data and send through a data warehouse, data lake, or a machine learning, training, anything, right? So this platform also brings you something called output streams. That means you could send information from the cloud into anything you want. And they also bring some plugins ready to use, like Amazon, AWS SKS, or PubSub from Google Cloud, or DataCake, or Azure Event Hub. Or if you're not using any of that, you can create your own webhook. And that's something that I will be using, for example, to control how long the device is on. And depending on how long it's on, I could just turn it off, right? So for example, one fail-safe I did that doesn't exist on the original Jacuzzi is like, if anyone turning on the Jacuzzi, I can turn it off in like 3 hours or 60 minutes or any amount of time I would like to use. So I'm also put here other information on the LightDB, and it's about how much time I will shut down users, for example, and I get the information from here. So I don't need a database until now. Let me see if there's another information. The temperature targets here too. So if I change on the WhatsApp part, the temperature I would like to make the bathtub reach, I can set here, right? So for example, it's 25 degrees right now. If I set this into 28, right? And submit the data, I add the refresh, and I'm just holding the sensor with my hand. The temperature is rising. Oh, sorry, I had to remove the clean state because the heater is. Let's see. Clean is false, heater is true, purpose is true. Oh, temperature is 29, so let's put in 32. Okay, so both, let's put my camera here together. Okay, so both are on. If I hold here, the temperature will rise to more than 32. I hope so. 30. 30, 31. 32. 32. So that's how it replicates information from each side, right? So next part about my code on the hardware part is like sending the information and receiving the information back and forth the device. On the setup mode, on the setup method, I have those two main informations here. Sorry, this main information which is connect. And beyond that, let me see if I have something here. Okay, I'm using those informations here. The first four libraries is about using JSON because the communication through Goliath is JSON, and also the Goliath library, the Wi-Fi library, the Wi-Fi security connection, and also the secrets.h, which is my key and all the information from I'm using to get access to Goliath, right? Basically, it's the pre-shared key, and I would like to share with you because you know it's live and it has been recorded. After that, I need to have some variable about the status, the Wi-Fi status, and then the Wi-Fi connection, and the client, the Goliath client, which is I use the method get instance. And here is where I set the client. Okay, so on the setup mode, I'm using the connect part, which does the Wi-Fi connection first. So the first block is like begin the Wi-Fi with the SSID and the password, which I can hover my mouse on Wi-Fi pass. And also, I'm counting how much attempts I did on this. And also, I check after the begin if I'm connected to the Wi-Fi. So they will loop this a while until the Wi-Fi is ready, right? Another thing, I'm using the delay mode here. The delay literally freeze your hardware for as many milliseconds you want. So I'm just delaying for 1 second here. And then I try each 1 second, I'm connecting, I check if it's connected. And if after 10 attempts, I just give up of connecting there. If it's connected here, I'm setting the certificate using the root certificate from Goliath. So they have his own certificate. And I'm starting to set up some information here. So here is the keys. That's the client, and then the Wi-Fi client, and then the keys. And I check if the client is connected, meaning that means MQTT is working back and forth. And I tried the same of the Wi-Fi here, but I tried 10 times and check if until the 10th attempt is the client is connected. And after that, I'm sending some information here that is about setting the callbacks when something happens from the cloud part. Okay, so I'm using this on DB message because I have a function that will handle all the data I receive from the cloud, and there is where I'm using JSON. And also I'm sending a command that I would like to listen to specific paths on my DB. So I'm listening for active, clean, bubbles, heater, and temperature target, because all the other data, it's the hardware sending to the cloud. So it doesn't make sense getting callbacks every time I change it, because if I change for here, I send to the cloud and then I receive a callback again, and doesn't make sense, right? So this part is about the connection. And on my loop part, this poll is super important because it is where the callbacks should be activated if you have something to call back. And also I'm checking if I'm connected here. So if I lose my connection, my Wi-Fi connection or my MQTT connection, I shut down all relays and try to connect again, right? So it's just like reboot the connection here without needing to reset or turning off the device. On the last part I was about to talk at the beginning, I did this and I'm just waiting each 5 seconds to send some data, because the loop itself is like when you finish the loop, it got backs on the beginning and you'll be running forever, right? So if you try every time the loops runs again, if you try to send something to the cloud, like I'm sending a pretty amount of data here, it is like your device will be completely frozen because you'll be trying to send too much data, and doesn't make sense because it's fine to like have 5 seconds delay, and you actually could like be more conscious about how much data you are sending there. So I set 5 seconds here. So I have a variable to store my current milliseconds, and I check if the current one passes more than 5 seconds comparing to the last one, right? And I'm adding the counter here so I can understand, for example, how much time the device is on. Even like I can remove this later, doesn't make sense. I'm also using this set lightDB state at path. That means I'm setting a JSON structure there, and I'm sending the temperature. I'm sending the information about if I can activate the pump and also the heater. So if some fail-safe is turned on from the device part, I'm just sending back to the cloud, and then I could take action. For example, notify someone because something is wrong with the device. And also I'm sending the milliseconds just to see it changing if I'm debugging, right? And I did this digital write built-in at high and low. So every time I send some information there, you'll be seeing the device blinking. So if you see the blue, just a second. If you see the blue light blinking just over here, that means the data is being sent to the cloud, right? So on the hardware part, it's pretty simple. You don't need to do anything more than that. Just make sure you put all the fail-safes you need if you're using hardware that could be harmful to people, of course. And that's exactly the case. Like you are using a jacuzzi that could turn on the temperature too much, could burn it on the heater, could broke the water pump. So there's some fail-safes you need to be careful. But also we could do this in any kind of project we'd like to use, right? So that part, I finished the hardware part. And now it's how that makes this thing more interesting, because it's time to get into the communication part. And I can promise you that will be more easier than doing the hardware. First of all, I'm using WhatsApp, right? So if you would like to create some interface on WhatsApp, first you need to use a WhatsApp broker or have access to the WhatsApp API directly from Facebook. And to make it directly from Facebook, you need to create a process on Facebook and verify your company, check if you are in accord with, in compliance with their regulations and some kind of, they don't just allow everyone to be there. So there's some companies that could not create accounts on the Facebook Business Manager. And to have a WhatsApp, you need to do this first, whatever you use Twilio or not, right? So on the Twilio part, to make your development process easier, and that's how, that's why we are developers, and that's why Twilio is focused on developers. We have on the Twilio console. So this is the console from Twilio. I have my account ID and my token, which is my secret to access the API. And here it's almost all products. Okay, if you create a new account right now, that won't be here because I just pinned some of I use the most here, so they are pinned here. But if they are not, you see export products. And I think I will refresh my page. Let's see, let's refresh my page. Okay, so when I export products, I go into messaging. You can click here and pin the messaging settings part. And what is most interesting about using the programmable messaging from Twilio is that, especially for WhatsApp, we have something called Sandbox, which means you can use a trial number from Twilio and test your application, even if you didn't start the Facebook process, and get the proper authorization. So you don't need to wait to develop that. And using the all WhatsApp interface, that means the interaction from the user will be closer than what the real experience looks like. So that's the best thing about using that. If you go into try it out and send a WhatsApp message from your account, you see that information. First, there's a term of agreement, and then you'll be moved into this page. And then they show these two messages here. So we have a common number. That's the number you need to use. And then a code that you need to send through your WhatsApp number. So that's how you tie your WhatsApp number with this account, this Twilio account, right? So that my code is join begun-sim, right? We won't need to use this right now because I already have a WhatsApp number, so we can try this directly from a number already set without the sandbox. When you do that, what has happened is on the end part, we will see. Let's do this from my phone number just to show you there. Just a second. So put them here. Okay, here is my account. I just add the number into my contacts list, so it's called Twilio there. So if I send join begun -seeds. Opa. Let me see if I sim. Okay, join -sim. Okay. So they receive the message here, so it's tied to my account. And then there's a little tutorial. You can send and receive messages. They also explain about what a template message it is. And that's mainly because you can send message to anyone from your side without having proper authorization. And also, since WhatsApp doesn't control what kind of communications we're sending to the user, to avoid spamming, they require you to register template messages to send to the user if you have not, if the user have not sent any message before, right? After the user sends something, you can send anything to the user. Here is the template number, the sandbox number, and also that's my number here, and that's the common message I could send right now. So if I create and make a request, they also show some examples here, and below is the information about the API call. So your appointment is coming up on July 21st. So that's okay. The message was great. And I also could test two-way messages here. So hello, City.js. And send it here. And then that's a pretty simple tutorial you can skip. And after you run that, you'll be directed to the Configure Sandbox page, which is on settings, messaging, then settings, then WhatsApp Sandbox settings. And here is where you can add your webhook, okay? So if you're handling messages or voice calls from Twilio, you always need to have a webhook. And this webhook could be tied into your own server, or in this case, I'm using something that Twilio also has, which is called Twilio Studio. So what Twilio Studio does is a visual interface to create conversations flows, right? So I already pinned my one here, and I go into flows. And I already have this Jacuzzi demo workflow, and we will work through that, right? So this flow, to understand the interface here, is like, let me do a little zoom here. You always start with a trigger. That could be incoming messaging, incoming call, or if you programmatically activate a flow using the REST API, or a subflow if you are calling a flow from another flow, right? So if I click on trigger, on the right side, I will have some information here, which is the webhook URL, and that's the URL I need to set up my my webhook on the WhatsApp Sandbox, right? So let's go back into there. It's here. I will paste my webhook link here and just click save, right? So after I did that, all the messages I sent to the Sandbox number, they will be getting into this workflow, right? And what you can do is like, on the right part, you have the widget library, or if you click on any component here, you see the details for the component, for the component or the widgets. So on the messaging part, since we are using WhatsApp, we have two main widgets, which is send messages, send message, or send and wait for reply. That means if you send a message, you just send a message and do nothing. If you send and wait for reply, that means the message goes to the user, and then you wait an amount of time that users could answer you back. Okay, so that's where the conversations, that's the widget used for the conversation. I will add this one so we can understand how we'll be working with. And I'm just connect here because I need to explain a little about some validations and how you can create like if or any kind of branches into your workflow. I will say hello from City.js. And what happens here is I click on the widgets, which is the send the message. I could send the message body and also add a media URL if you are working with media. That means you can add PDF files, audio, anything else. And every time I change something, I could hit publish here, right? So before sending this message, oh wait, I would just let this something here. I would disconnect here because I'd like to start from 0. So I could like connect the message into here, and that's the only thing will be happening here. So if I didn't connect the sent button here into any other widgets, my workflow ends right now, right on this part. If I connected something else, like for example, a send, a wait for reply, my workflow will be active until the timeout is over or any other behavior I expected, right? So if I go back into my cell phone, and now if I say hello for City.js, if I say anything that's anything, it is still sending hello from City.js, right? So, but what I need to do is, since I did a little hack here about my device, and I'm using the first part of the name to identify my device, that means I need to send this code into my flow on the first message, right? And I need to check that. And for this, Studio has another widget, some widgets based on flow control. And the first I'll be using is called split based on, which is like a if else or a switch case command, right? So what I can do here is like I choose a variable, which means I'm getting a variable from some place or some widget, and then based on the value of this variable, I will be creating some decisions or some flows that will be reached after that. So I will connect my first message into this split based on widget. And what happens here is I can create other matches here. And what matches I could use? For example, I could use equal to, there's multiple, like equal to, not equal to, matches any of a list using comma, doesn't match any of a list using comma, is blank, is not blank, uses a regular expression, contains, does not contain, starts with, does not start with, less than, greater than, is before time, after time, dates. So that's the how many elements I can use here. And what I did here is like I use a regular expression, and everything needs to start with this code, which is Cosmopolitan, the name of the building, Jacuzzi, and a number between 1 and 3. Of course, I just have one hardware here. So if this code, the first message received came with this pattern, I will go into the next element of this flow, right? So the next element of this flow is another thing called set variables. So I'm using this widget because I need to set some information from the URL I'll be using to set the data into Go Live platform, right? And I will be needing a backend here. So first, I need to set the device element, and the device element gets the variable from the trigger. So it's trigger.message.body. That means the body of the message I received that triggered this flow. And I'm using something called liquid language here. So I could add pipe uppercase. So I make sure even if you send everything lowercase, when I save this information, everything will be in uppercase, right? It will be capitalized or uppercase. And then I checked other information, that is, if the user, if the phone number who sent the messages is me, or if is the manager of the building, I'm adding him as an admin, right? So let me see if I could check. oh yeah, the first name is my one, and you already saw it, so that's fine. So I match any off, I put comma here, and if you came from WhatsApp, you have to use this WhatsApp prefix, right? And if matches that, I set another variable called is admin equals true. And after that, I just make the URL and call another widget that's create an HTTP request, which is the URL I mounted here. I can show you there. So this URL is my address from my server /device / the ID of the device, right? So I send that, and when I receive the answer for this call, a successful answer, I will check what comes back from there. So my server could answer with a JSON file, with a JSON object, and then I could use the studio to check the information there. And to check the information is I need to get the widget name and use this dot parsed. So I'm transforming the answer for the call into a parsed JSON, and I'm using this variable called wait for reply. That means if this device, if I should send into send a wait for reply widgets because the user needs to complement with some information, or if I just send the information back and I could end the flow, right? So that's why I'm checking this information, because, for example, if the user asked to change the temperature, and that's what I'm checking here. So if the user, for example, send the on/off command or the temperature, or a command that is connected to the manager, for example, could block the jacuzzi for everyone, for example, on weekdays, or he could allow it to anyone. And also he could send a cleaning command, okay? So that's what's happening here on the first part. And other thing that's set here on the widget is like how much time the user has to answer the command. So I set 30 seconds. If past 30 seconds, I could trigger another flow called no reply, and then I could end this flow, and the user needs to send the jacuzzi code again, right? So if the user replies with something, I check which is the command he sends, and based on the command, which is numbers from 1 to 5, I could be allowing them or sending the command back into my backend, and my backend will allow that. And also, for example, if the command he sent is about temperature, I ask the user which temperature he would like to set, and I check the temperature if it's between 5 and 40 degrees. He could send any temperature that not is between those values. And that's it. I just send the code again and adding the temperature information if that's the case, or adding, for example, on/off is pretty simple. They don't need to request any other information. Temperature request information. And the admin part, I check if the user is admin. And if it's admin, I'd send the command forward to the request. So the code is basically that. You don't need to create too much complexity here. But now is the part of the backend to conclude this presentation. So I have another Visual Studio here. And we have some functions to connect to the GoLive IoT. Let me remove some elements here so we can go directly into the first part. So remember that I'll be connecting to WhatsApp, and the WhatsApp will send the message to my backend, and my backend will send the commands into GoLive, right? So first part I need to work with is this one. which is the studio sending the HTTP request to my device. I'm using it here because I was debugging, but you can, for example, add security, verify user, add some token, check if the request came from Twilio. So it's possible to validate even the data sent to you. I'm checking if I receive the device tag parameters and also the command. The device tag is obligatory, but the command it isn't. I'm using this command get devices, which means I could open right now. And what happens is I'm connecting to GoLive endpoint, passing my API key I have from there. And this GoLive address is just this URL. So api.golive.iot/v1/projects, your project ID, and /devices. So you can, if you just access this, you can get a list of devices, and you can do more if you send, for example, a post command for a specific device ID, right? So I did this, but I'm not using anymore. It's the ID of the device. So every time I'm sending a command, I'm checking using that first prefix of the device name. And also, I need to use the API key, the project ID, which is on my environment variable. So you won't be seeing here, right? So when I get the devices, I'm just getting the data back. And then I check, I use a filter to check the device name with the prefix. So that's how I skip to use another database to do this part. And then since I have the device, the next thing I'm doing is getting the data from the device from GoLive. So I'm also using Access here. And what happens is I append more information about the device, including the device ID, /data, and /path, which means if there's any specific data I would like to get into the LightDB, right? Also pass as on the Redis my API key, and then I get back the data from the results and go forward with my command, right? So also I'm using the device name because I would like to create an interface that is more understandable for the user. And instead of just say CMP, etc., I'm saying the name of the device. And also I'm doing it here also some security checks and other verifications, right? So I'm checking if the device is active, because, for example, if my failsafe is on and the user tried to turn it on again or change the temperature or do something that he couldn't because the failsafe is on, I need to tell the user I won't be doing that, or at least I tell the user like, hey, I can work with this method right now because that is happening. And he could like call the manager or ask for help. That happens if his device is on. That means even the pump or the heater. And also if this bubble is active, it's about checking if the pump is active. A heater active is like checking the heater and also if it's possible to activate the heater. Then remembers that I'm checking the command. So I think I could show you the interface now so we can see it working. See, it's connected and also it's published. So if I go here and send, I forgot the name of the component. This it's here. I can close this. CMP DN GCC what? Hello from CGS. Okay, so sorry, because it's in Portuguese, but what's telling me, okay, forget to add this info here. So hello from CGS, the first widget. The jacuzzi rooftop right is on, it's working. The temperature schedule is 26 degrees. The current temperature is 26 degrees. It's programmed for 32. What do I like to do? Turn it on, the jacuzzi, change the temperature, activate cleaning modes. Number 4, block the jacuzzi, add some people or remove someone. So I need to send again the code because it passes the 30 seconds. So I just copy here and have this on my memory. Okay, so I can turn it off, jacuzzi. Let me show the LightDB state here so we can see everything happen together. Seconds. Let's turn it off. That means just one other information. Here I put some failsafe also because I can turn it off the heater after many seconds. I need to turn the heater off first, and then I turn it off the pump. I don't remember how much seconds I put that. Let me see on my codes. So shutdown is 15 seconds for the pump. And there is something else I should like to set up here. So why is not turning off? Because I don't have right now something on my database or some kind of trigger that in 50 seconds, it could update the state, right? So how I'm doing this? Since I'm sending messages here every 5 seconds, so I could add another thing on Go Live platform that is the streaming. And I keep on the streaming into my webhook, right? So I'm just activating this right now. And the pump should be turned off in a few seconds. Just turn it off. And what happens is on my backend, I have another function here that let me put the refresh here. I have another method here that is about receiving the data from the streaming. And if I receive information about milliseconds, I check it, for example, the temperature. If that both my local hardware and the cloud is doing some fail-safes. And if the temperature rises, no matter how or why, the maximum temperature, I also send the shutdown command from remote. And also, if I have this parameter called bubble shutdown, which means if it's there, I need to shut down to change the pump into off in an amount of time. I check that, and if that happens, and the current date and time is greater than the time I programmed the shutdown, I also send the shutdown command for both the heater and the pump. And what I did that is I do the heater first, and then I change for more seconds and turn the pump off too. So that's how I create this delay instead of just sending a shutdown command into the device. So that is being done by the cloud using the web stream. What else? So Let me get here. I can, let me put the camera to this camera. Okay, the camera is here. So we can see the element here. What will be happening right now is since I turn it on, I turn it off, I put here. And then, for example, I could block the jacuzzi for everyone. Right, so if I send command 4, active change it to false. So if anyone tried to send this message here, the code, the message that the people will be receiving is the jacuzzi is not scheduled to work today and no one can do anything else. If I send the command 4 again, they will activate. And if other person send the code, what happens is I have the message here. This one, so I just turn it on the jacuzzi. And also I could change the temperature, but what I'll be doing right now is like, I will get the sensor, turn it off the sensor. That means it could be working now, right? So if I send the command here, it is meaning that there's not enough water to be activated. So we can, for example, this is easier for example, from the manager of the building, understand what's happening on jacuzzi, and also make sure that you are sending the clear information for the developers, for the users here. And that's something pretty cool to use, and is a pretty simple interface to work with. So here's the timeout again. So I invite you to try it on yourself. And that's a QR code you can scan and open WhatsApp. And let me do something here because I put the QR code here. And you'll be using, I'll be showing the state here. And we can see the camera. So just a second, and we can finish this workshop. So I will turn it on. You can also send comments like let's put this over here. So it's on, it's 37 degrees. I will move into 32. Let's put this here. If you send the comments to, we can change the temperature. So maybe you can send the comment to here, and then let's see, 38. 38. So you can send comments from your device. Like if you can send one, you'll be turn it on and turn it off. So I'll be seeing visually what's happening here. And also if you send the temperature change, that also will move some things on the hardware. So if I set 32 here. Oops. Okay, I need to send again. I send command to temperature between 5 and 40, 32. 32. the temperature just set into the database, and since it's below the current temperature, it will turn it off, the heater. And that's it for all. I think we finished it. So do you have any questions? Would you like to discuss something else?
Yes, Luis. I have a question about the Twilio WhatsApp SDK. When I'm in the development mode, how exists some rate limits for to do some requests and things like this?
You have, for example, there's two situations here. If you're using the sandbox mode, the sandbox mode is just for prototype, so don't put anything in production on sandbox mode, especially because your tie into your phone number and the sandbox mode, it automatically got cleaned from time to time. So does that make sense? You sending the joining code every time you would like to test it. Also, thinking about the production part, if your WhatsApp is in production, we have Facebook actually have some kind of limits, which is if you start your account right now, you can send or receive messages to 1,000 contacts per day. But there's a way you can like warm up your WhatsApp number. So what happens is, for example, if you send 1,000 messages today, 1,000 contacts, doesn't matter the amount of messages, but contacts, 1,000 contacts today, 1,000 contacts tomorrow, and the day after, if you don't have, for example, reporting for spams or anything complaining about your messages, you automatically get upgraded into the second tier. So the second tier is 10,000 contacts. And then if you do the same thing on the next day after the sequence of sending 3 days, 10,000 messages, you get upgraded into 100,000 and so on. If you're planning, for example, doing things like interact with the users, that will be pretty easy to do if you have an amount of users. But usually it's like you need to think more what you'll be using on WhatsApp, especially because, for example, Twilio have some kind of products that uses WhatsApp for example, two-step authentications. There's a new release called Twilio Verify for WhatsApp. And it basically sends OTP messages to users. And since it's using the Twilio WhatsApp account, you don't need to worry about limits. But that's a specific use case about user authentication and verification. If you're working with chatbots or services or notification service, you need to have a clear understanding about your strategy to warm up your number until the amount of users you'd like to contact. But if, for example, if you're building a product or starting a startup that don't have too much clients, you'll be fine because 1,000 contacts is like a lot of contacts. I think on my demos or projects that I interact with a lot of developers, I never reached the 1,000. So that's something you need to have in mind when you're building with WhatsApp.
Awesome. And for those who want to do just a little application, a personal application, it really has a free tier for some pay rate or forever.
For WhatsApp, we don't. I mean, because there's some needs you have to pay directly for. That's something you need to pay to Facebook, when, not only to you, right? So if you are, for example, sending message to the user, right now, a few months later, I think Facebook changed how they pricify things on WhatsApp. And you can have a free tier from Twilio or Facebook, because there's some things you have to pay to Facebook using through Twilio. Twilio pay to Facebook your message, right? So for example, right now, the way Facebook charges your account is they create some, they use conversation windows. So you pay a fee to Facebook for every conversation window you open in 24 hours. Before that, it has another way of specifying this, because before these changes, Facebook charges you when you send a message to the user without this conversation window. And this message should be a template message. And now they are just charging you when you start or when the user sends you a message. So I don't have an opinion about which one is better, but that's right now the way Facebook works with WhatsApp. So that's the main reason we also don't have a free tier for messages on WhatsApp. But if you create a Twilio account, for example, for messaging, we have the trial account could start with $15, and you also could use that for sending messages. But I believe it's more about developer purposes, because after you upgrade from trial is where you, for example, need to buy a phone number, and this number is tied to your account and it looks more like your real project in production. So it doesn't make sense too much. But of course, Twilio, if you are a startup, for example, Twilio have some programs for startups with credits, and I invite you to check twiliostartups.com. So there's a way you can apply to receive credits, and those credits, that's like our upgrade credits. So you don't need to use, for example, testing numbers or anything else.
Luis, do you have any other related videos or information for the people that are watching us that they could watch? Do you have like other videos like the one you gave, which was really amazing and I really enjoyed it?
We have some. Let me see if I can see the webinars here. You can check this link, Twilio/webinars. I will here too. It's a little outdated because we are changing this page, but here you can find, for example, webinars, and not only about WhatsApp, but multiple all the products of Twilio have, and also there's some Lift Off Brazil, for example, is a series of 3 webinars that we have. We talked about how to scale communications. So, for example, limits, how to work with limits, how you can improve your security from your Twilio account into your application, and verify all those requests and make sure that everything is valid and secure. And this is not only in Portuguese, but also have content in English as well, in Japanese. I don't think you have for Spanish yet.
And what other events are you planning for Twilio? Is there any other events that you would like to invite the people and maybe they can talk to you?
We have planned, but it is not on. We don't have a registration page yet. So we are planning a lot of events, a lot of webinars. We kind of separate Twilio webinars, and when, for example, I'm doing talks at conference, etc. If you're in Brazil, we'll be hosting a free Twilio track at the developers conference. The next one will be in June. Will be hybrid, so we'll be in Florianópolis on the south of Brazil. But also the Twilio track online will be free for everyone, and I can promise you we talk about a lot of content, not only about Twilio. So we invite people from the community to speak there, and also if you are a developer and would like to present something, call me, send an email. So I'll be glad to invite you to present at TDC. And about webinars, the best way to check that is twilio.com/webinars. We are working to get all of them there. Just get a link here.
One more question. When is the next Twilio festival? Because you have an amazing conference that you do every year.
Signal. Twilio Signal.
Yes, that's the one.
Yeah. Signal will be in November. You'll be hybrid in November 2nd to 3rd. That's the main conference Twilio does every year. And when we launch products, we bring user cases, and there's a conference that focuses on developers and on companies. So that content exclusively for developers there. This time we'll have some specific keynote for developers, and I'm pretty excited about that. If you'd like to join us, that's the link I can send to you here in the chat. And we are thinking about having some watch parties on some regions. I'm sure that we have one in Brazil, but if you attend any Twilio webinar, or for example, if you subscribe on these webinars here, you'll be receiving emails from me, so we can be up to date about what we are doing here and see our events.
And one last question. Would you like to tell us a bit about the talk that your colleague is going to give in CityJS on Saturday? Would you like to do like an introduction to the people that are working with?
Sure. So Gabriel, he just started at Twilio, so he's my new fellow teammate here in Brazil, and he's also serving Brazilian developers. He's been working about feature toggling in JavaScript, which means how we can programmatically activate features in your code using an approach that could plan in a structured way on how to put features in production, and also some patterns that could help you develop better JavaScript applications. So I'm pretty excited to see Gabriel there, and I invite everyone here to attend too.
Thank you very much. It was amazing, and we had people from all over the world. I checked on Twitter as well. The majority of the people, they were from Brazil, but there were a lot of people from Germany and from other places. So yeah, everyone give a warm clap for Luis. He also did it in English, which initially we planned to do it in Portuguese, but you did really well. I'm quite impressed.
We changed it.
Oh yeah.
I'm glad we are here. So yeah, my pleasure. Spoken both English or Portuguese. So yeah.
And thanks for everyone for joining, and I look forward to see you. I have brought more than like 50 t-shirts from CityJS from other places. So come on Saturday, or I think we have an event tomorrow. And yeah, join us tomorrow. It's an in-person meetup. If you can come, it will be great. But other than that, I will see you around in Sao Paulo. It's very warm and nice and very tropical, and I'm loving it. So yeah, thank you everyone for the welcome and everything. Okay, bye for me, and thank you very much, everyone. Obrigado.
Bye, guys. Thank you for meeting.
Bye. Bye.
Bye.